With variables involved as well, but we see a radical in the denominator, still must rationalize that. So we're going to multiply this by a clever version of 1, again, so that the denominator rationalizes. What times what? What's going to be my clever version of 1? My clever version of 1 in this case is a 5y, because 5 times 5 is 25, and that's a perfect square. Y times y, it's y squared, and that's also a perfect square. So I'm going to use root 5y over root 5y as my clever version of 1, multiply through. So in the numerator, I will get the root of 15xy. The denominator becomes the square root of 5y times the square root of 5y, and that is 5y. I can't simplify any further. This 15 and the 5, this is a root. This is not a root, so I can't combine those or divide those out in any way. I can't cancel those y's out for the same reason. You need to be careful of that. So that is my final simplification. For this one, recognize first that we're within a cube root. So I need to figure out what's my clever version of 1 in cube root world. So to identify that, it might be helpful for some of us to rewrite this as cube root of x over to cube root. 36 is also a 6 squared. So if I can recognize that, then I can see that I need to have a total of 6 cubed in my final version. So let's multiply my clever version 1 to be a cube root. It will need to contain a 6. I have a y, but how many total y's do I need for a perfect cubed? I need 3 total, so it'll be a y squared here. So there's the formation of my clever version of 1. So let's turn that all into a clever version of 1. Then we can go ahead and multiply across. This becomes the cube root, multiply the insides, 6 times x times y squared. I like doing constants, then variables, lowest to highest. And then the denominator, cube root. 6 squared times 6 is 6 cubed. And then y times y squared is y cubed. Notice my version of 1 was the best one that would make my denominator all perfect cubes. Reduce and simplify the numerator. Not much I can do there. There's no perfect factors or perfect cubes that are factors of any of those terms. In the denominator, the cube root of 6 cubed is a 6. The cube root of y cubed is a y. And there I'm simplified. Again, I can't cancel out the 6's or the y's because these are cube roots on the top and no roots on the bottom, so they're not like terms, and therefore I can't cancel or factor them out, which means I am simplified. One with a 5th root in the denominator, so I need to be thinking about 5th root world. What's the perfect number that will make the denominator all become perfect fifths? So let's go slowly. And one thing I might do first is I'm going to rewrite the denominator. I notice there's 4 in here, and I notice that 4 is also the same thing as a 2 squared. Now doing that does allow me a little bit to figure out what my clever version 1 should be. In order for 2 squared to become a perfect fifth, I need to have another 2 cubed to it. So part of my clever version of 1 will be a 2 cubed. Change gears a little bit. With x squared, or x cubed, I need to have a total of x to the 5th. So this will be x squared. And I have a y. What's the total amount of y's that I need to have a perfect fifth? That's y to the 5th. So there's the starting of my clever version of 1. Let's complete that. There. That's a heavy, clever version of 1, but it's the best one that I can find that makes the denominator rationalless or radicalless. So let's go ahead and multiply the top. All right, I got some stuff going on here, so we're going to go ahead and figure out what we want to do here. Oh, okay. I saw what I did wrong. You guys caught that, didn't you? I was saying fifth. This is really need to be a y to the fourth, because y times y to the fourth makes y to the fifth. So my numerator, 10y times the fifth root of all this stuff. That fifth root, there's nothing in it that has a perfect fifth in it, so I can't reduce that. Denominator, this times that produces a fifth root of 2 to the second times 2 to the third is 2 to the fifth. X cubed times x squared is x to the fifth. Oh, I love seeing all those fives. Y times y to the fourth is y to the fifth. Boy, do you see how that clever version 1 just kind of made that denominator all nice and pretty? And then finally, let's be really careful, write down the numerator with all that stuff in it. 10y to the times the fifth root of 2x cubed, y to the fourth. The denominator becomes a 2x, y. It is reduced, it is simplified. I know it looks a little bit more ugly than what we started with, but the key point is that there's no radical in the denominator. And now we can say it is simplified.